Hello students, today in the third video of periodic classification of element, we'll continue with the modern periodic table students. Modern periodic table is based on modern periodic law and it is given by the scientist name is Henry Moseley students. The scientific world, when we will talk about scientific world, till before this Moseley, till Mendeleev, all were knowing only about the atomic mass twins and they were talking about atomic mass only. They were not having any other option. But after Mendeleev, when he gave his periodic table, Mendeleev's periodic table, later on, after a long time, the scientist world did till that time till Mendeleev, they were not knowing about the intermolecular atoms students, sorry, interatomic particles. That means they were knowing only that the atom exists. Atom is the smallest particle. They were not knowing that inside the atom also there must be something, and atom is also having interatomic particles students. So here, after long back, after the Mendeleev's periodic table, scientists, they come to know about the interatomic particles students after the discovery of electron. After the discovery of students, now we know that inside the atom electrons are there, protons are there, neutrons are there. But before sorry, this Henry Moseley, till Mendeleev, the scientists were not knowing about interatomic particles students. They were not knowing about electron, they were not knowing about proton and neutron students. After the discovery of electrons, scientists started exploring the relation between the electron number of an atom and the atomic number students, and the atomic number. In 1913 AD, the English scientist name is Henry Moseley demonstrated with the help of the experiment done using X-ray tube that the atomic size Z of an element corresponds to positive charge of us on the nucleus, or the number of protons in the nucleus of the atom in that element. This related that atomic number is a more fundamental property of an element than the atomic mass. Now, after the discovery of electrons, they were knowing about the atomic number students. They named as the number of electrons is the atomic number. It is equal to number of proton present inside the nucleus, and they said the atomic number is a more fundamental property as compared to atomic mass. They means here, Henry Moseley said. Now, according to statement of the modern periodic law was stated as follows. Students, the same statement is there as it was there in Mendeleev's periodic law. Same statement is there. Properties of element are periodic function of atomic number. See here students, atomic mass number. Previous, when we were doing Mendeleev's periodic table, here instead of atomic number it was atomic mass number. So here, there is a change of a letter. Atomic number is there instead of atomic mass. Here Moseley, Henry Moseley, what did he do? He took the same table which is given by Mendeleev, and he just did one change. What he did, he just replace the atomic mass by atomic number students, atomic mass by atomic number, and because of that the totally that Mendeleev's periodic table is changed, and today we are having modern periodic table. So students, you will remember the properties of element. When we are talking about properties of element, are the periodic function of their atomic number according to periodic modern periodic law. Here students, I'll show you the picture of modern periodic table. See here students, this is the modern periodic table. Here this is the picture of modern periodic table. What he did, what the Moseley Henry did, he just arranged the elements as per the atomic number, as per the atomic number in the increasing number of the atomic number students. In the increasing atomic number he arranged the elements, and he prepared the modern periodic table. Now this is the periodic table which is famous and we are learning till now. It is long interval of time after Henry Moseley. Till now there is no question mark on this modern periodic table, and this is useful for us to study the different elements, students, different elements. Students will discuss about modern periodic table, structure of modern periodic table. When we'll talk about modern periodic table, students, in modern periodic table we are having horizontal rows, and these horizontal rows are named as period, students, are named as period, whereas vertical columns are also there, students, vertical columns are named as group. So here we are having groups and periods in modern periodic table. In modern periodic table we are having groups and periods. When we'll see horizontal rows are called as periods, students, horizontal rows are called as period, whereas vertical columns are called as groups, students, vertical columns are called as groups. So let's see how many periods and how many groups are there in the modern periodic table. When you will see in modern periodic table, 1 2 3 4 5 6 7 periods are there, students, 7 horizontal lines are there, and they are called as periods, students. In the same way, when you will see, when you will count 1 to 18, 1 to 18, total 18 vertical columns are there, that means 18 groups are there, students. So here we are having 7 periods and 18 groups, 7 periods, students. 1 2 3 4 5 6 7 periods are there, students. And in the same way, 18 groups are there, 18 1 to 18 groups are there. So here horizontal rows are called as periods, and total 7 periods are there in modern periodic table. In the same way, vertical columns are called as group, and total 18 groups are there in modern periodic table. This is about structure, students. We are learning structure of the modern periodic table now. On the base, not only the rows and column, the modern periodic table is divided in blocks also, students. Modern periodic table is divided in block. Now which are the blocks, I'll tell you, students. Here modern periodic table is divided into blocks also, students. When you will see first two groups, first two columns, students. First two column belongs to the S block, students, belongs to the S block. When you will see the call in the middle, third to 13, students, third to 13, group 3 to group 13. I'll show you in a real picture, students. Group 3 to group 12, this all belongs to the D block, students. They belongs to, I'll show you, students, I'll show you. Here they belongs to D block. And from 13 to 18, they belong in P block. They are in P block. And at the bottom of the modern periodic table you will see there are one lanthanide and other actinide series are there, students. Lanthanide and actinide series are there, they belong in F block. I'll repeat, students, I'll repeat again. Here modern periodic table is divided into blocks, students. Total 4 blocks are there in modern periodic table, and these blocks are like this. First two columns are called as groups, students. Here, so here first two groups, they belong in S block, students, they belong in S block. When we will talk about 3 to 12, these all transition elements, they belong in D block, students, they belong in D block, they are called as D block. Whereas 13 to 18, this group is called, these all groups are in P block, students, are in P block. And when you will see at the bottom, at the base of the modern periodic table, there are two, one is lanthanide and other is actinide series are there, and they are in F block, students, they are in F block. So you will remember this. And this is structure of modern periodic table. This is structure of modern periodic table. Let's go ahead. When we'll go ahead, students, here in modern periodic table, in P block, students, in P block, here you saw what is P block. Here this block is called as P block, students. In P block you will able to see a zigzag line is there, students. zigzag line. This zigzag line, along this zigzag line is formed by the semiconductor students, metalloids. Semiconductors means metalloid students. So here, when you will see modern periodic table, I'll just show you modern periodic table. You can see students the green color boxes, when you will see this green color boxes students, here these green color boxes, they are showing the metalloids students, they are metalloids. So here we are having metalloids. This zigzag line divides this modern periodic table in three parts students, divides this modern periodic table in three parts. When you will see left side, when you will see left side of the modern periodic table, on the left side of this zigzag line, it is called as metal students. On right hand side it is non-metals, and this green color boxes, they are semiconductors or metalloid students, they are semiconductors or metalloids. So you will remember this students, you will remember this students. This is about structure of modern periodic table. This is structure of modern periodic table. I'll tell you few more things about modern periodic table, and we'll continue with the chapter students, we'll continue with the chapter here. So here students, till now you have studied in modern periodic table. There are horizontal rows are called as periods. There are total 7 periods are there. When you will count, 1 2 3 4 5 6 7 periods are there students. There are total 7 periods. When we'll talk about columns, there are total 1 to 18 columns are there. 1 to 18 columns are there, and these 18 columns are called as groups students. Columns are called as groups in modern periodic table. So we are having total 18 groups. This is about rows and columns students. Not only rows and but columns, but also here group 1 and group 2 is called as uh, S block students, S block. Whereas group 3 to group 12, they are called as D block students, they are called as D block. And group 13 to group 18 are called as P block students, they are called as P block, they are called as P block. And at the bottom, when you will see at the bottom, lanthanide and actinide series are there. Lanthanide and actinide, see here, lanthanide actinide series are there, and they are called as F block. So here modern periodic table is divided into four block also. I'll repeat again students. Group 1 and group 2 are there in P block students, are in P block. Group 3 to 12, group 3 to group 12 are in D block students, are in D block. Group 13 to 18 are in P block, and at the bottom, lanthanide and actinide series, they are in F block students, they are in F block. So you will remember students, you will remember this. Other than this, when we will continue with the modern periodic table students, one zigzag line is there, and this zigzag line shown is a green color blocks students. Green color blocks are there. These green color blocks are um, students metalloids, or metallites are also known as semiconductor students, are also known as semiconductors. These semiconductors, when you will see right hand side, on the right hand side, the non metals are there. When we will take this zigzag line as a reference, on the right hand side of this zigzag line, we are having non-metals, whereas on the left hand side of this zigzag line, we are having metals students, we are having metals. So here, on the basis of this zigzag line students, we can divide the modern periodic table in three regions. One is metals, non-metals, and metalloid students. Along the zigzag line, green color boxes are metalloid students. Right hand side it is non-metals, and left hand side it is metal students. So here we can divide modern periodic table in three parts. Not only this, but also students, there are few more things which I'll tell you about the modern periodic table students. Here, when you will see group 1 is known as alkali metal, students. They are known as alkali metal, whereas group 2 is known as alkaline earth metal. So here, that you will remember, students. Last group 18 is called as zero group elements, or group of inert gases. Group of inert gases, students. They are having valency 0, that's why they are named as zero group elements, students. They are in octet, students. That means their outermost orbit is in stable form, and that's why they are inert. They don't react with others. They are called as inert gases also, students. When you will see group 17 is called as halogen, students. Halogen means salt forming. They form salt when they react with the non-metal, metal, students. When they react with metal, they form salts. So that's why they are called as halogen, students. Halogens means the one who forms salt forming, students. So here this is about the group 17 is known as halogen, students. When you will talk about 3 to 12, group 3 to 12, they are called as transition elements, students. They are called as transition elements. When you will see lanthanide and actinide series, they are in the modern periodic table only. When you will see this green color, this is for this place is for lanthanide, and the second red color, when you will see, it is for actinide, students. But when we will talk about lanthanide and actinide, they are found in series, students. They are found in series. There are number of there are series of this lanthanide and actinide. So here in detail they are explained at the bottom of the modern periodic table, students. At the bottom of the modern periodic table, so you will remember this is the structure of modern periodic table, students. Let's go ahead. On the basis of this structure, and detail about the modern periodic table, we'll discuss about some properties of elements, of atoms, students. And then we'll compare these properties with the modern periodic table. So let us continue, students. Let us continue. Just a second, I'll take you to the valency, students. Now we are going to talk, and we are going to discuss about valency, students. When we'll talk about valency of the elements, valency of an element is determined by the number of electrons present in its outermost shell, called valency electrons. So here valency is determined by valency electrons, students. Valency is determined by valency electron. Just a second, students. Before we'll continue with the valency, I'll just explain you what is valency is it. Students, when we'll talk about valency, students, valency is the number of electrons required, to complete the octet. That means to be stable, students. To be stable, when I'll talk about, for example, when I'll talk about sodium. When we'll talk about sodium is having electronic configuration, atomic number is 11, students. So electronic configuration will be 281. Here when you will see last orbit number of electron is 1, students. Number of electron is 1. So when number of electron is 1, either the sodium will have to take 8 electrons, or will have to release 1 electron. There are two options. Sorry, not 8 electrons, it should be 7 electron. It should be 7. So sodium will have to take 7 electron, or leave 1 electron, because in the last orbit it should be minimum 8 electrons must be there to be stable. So here there is requirement of 7 more electrons, or it will have to release 1 electron. Then only the last orbit will have 8 electron, and the sodium can be stable. Sodium, to be stable, either sodium will have to take 7 electrons from somewhere, will have to arrange 7 electrons, or have to release 1 electron. So students, here it is easy to leave 1 electron, it is difficult to search 7 electrons. So here 7 number is greater than 1, so here 1 is easy to release, and that's why the sodium will release 1 electron. And when it will release 1 electron, its electronic configuration will become, here only electronic configuration will become 2 8. This one electron is released, we will put 1 plus sign. Negative electron, whenever we release, we acquire the positive charge, students. So here sodium releases one electron, and sodium ion is formed, students. Sodium ion is formed. Now it is stable. Sodium is stable now, students. Now here one electron is given, that's why we'll say the valency of sodium is 1, students. Students, will talk about valency in detail in next lecture. Today we'll stop here only, students. For today, thank you very much, students. We'll continue this in next lecture.